So hello, I am Jerome Martin Tolentino from BSCE 3A, and in this video I am going to be discussing and solving problems on the rectilinear kinematics erratic motion. So without further ado, let us start. So for problem number 1, we have with the acceleration shown in the figure below, a particle moves in a straight line motion. Plot the vt and st graphs if the particle's motion starts from the origin with an initial velocity of negative 14 feet per second. Also, determine the particle's maximum velocity and its position coordinate. So this is how our graph looks like for problem number 1. So the first thing that we are going to do is we are going to analyze and list all the time frames or time intervals that this graph has. So we have 0 less than equal time less than equal 2 seconds. This part. And then for this one, we have 2 less than equal 5 seconds. There. And then we also have 5 to 8 seconds. And then lastly, for the final time, we have 8 less than or equal. I am just going to label this as TF or final time. So there, these are our time frames or time intervals. So the next thing that we are going to do is we are going to solve for the velocity in the given time 0 at 0 to 2. Here we have a given value for acceleration, which is 3 feet per second squared, and also an initial velocity of negative 14 feet per second. So the formula that we are going to use is the formula for the change in velocity, which is the integral of a dt. Since we have a given acceleration, the next thing that we are going to do is we are just going to substitute the value of a. So the integral of a, which is 3 dt, limited to 0 to t. So this will become 3t to t. So since this is already 0, we are not going to do anything about that. So this is the value of our change in velocity is equal to 3t. So another formula for the change in velocity, in order for us to get the velocity, is we are going to sum up the change in velocity and the initial velocity, which is this one, the negative 14. So velocity is equal to the change in velocity, which is 3t, plus the initial velocity, which is negative 14. So there, this is our value for velocity in 0 to 2 time. So the next thing that we're going to do is we are going to substitute the given values of time for when time is equal to 0, then velocity is equal to 3. Substitute the value of t, which is 0. So 0 minus 14. So that 3 multiplied by 0 is 0, so negative 14 feet per second. So this is our first value for velocity when time is equal to 0, and when time is equal to 2 seconds, velocity is equal to 3 multiplied by the time, which is 2 seconds, 2 minus 14, we have 3 times 2 is 6, 6 minus 14, we have negative 8 feet per second. So these are the values of velocity in 0 to 2 time. The next time frame or time interval that we have is at 2 to 5, which has an acceleration of 8 feet per second squared. So the initial velocity that we are going to use here is the velocity in 2 seconds. So that is 8 negative 8 feet per second. So again, the formula for change in velocity, we have the integral of acceleration multiplied by dt. So the value for acceleration, we have the integral of 8 dt limited to 2 seconds, and then t, which is yung hindi pa natin alam na value. So integrating, we have 8t limited to 2 so since ito na yung 8t minus yung limit na 2 multiplied by 2, so 8t minus 16. So this is the value for the change in velocity for this problem. So in order for us to get the velocity, again, we are going to just add the change in velocity, which is 8t, to the initial velocity that we have, which is negative 8. So negative 8 minus 16, we have negative 24. So this is what we are going to use in this problem. So for time, when time is equal to 2 seconds, we have v is equal to 8 multiplied by 2 minus 24. So 8 times 2 is 16 minus 24. So negative 8. So same lang. And then when time is equal to 5 seconds, so 5 seconds, we have v is equal to 8 multiplied by 5 minus 24. We have 40 minus 24, we have 16 feet per second. So again, these are our values for velocity in 2 to 5 seconds. So the next one is at 5 seconds to 8 seconds, which has an acceleration of 3 feet per second. And again, the initial velocity that we are going to use is the velocity in 5 seconds, which is 16 feet per second. So again, the formula for change in velocity, we have the integral of a dt. So again, the value of acceleration, which is 3 dt limited to 5, and then t, which is unknown. So integrating, we have 3t minus 3 multiplied by 5 seconds. So we have 3t minus 15. Again, this is the change in velocity. To get the velocity, we are going to sum or add the value of change in velocity to the initial velocity. So we have 3t negative 15 plus 16, we have 1. So this is our value for velocity. So when time is equal to 5 seconds, velocity is equal to 3 multiplied by 5, t, substitute, plus 1. We have 3 times 5 is 15 plus 1, 16 feet per second. And then when time is equal to 8 seconds, we have 3 multiplied by 8 plus 1. 3 times 8 is 24. Plus 1, we have 25 feet per second. So these are our values for velocity in 5 to 8 seconds. And then for the next one, we have at 8 seconds to the unknown time or the final time, DTF. So in this one, we have an acceleration of negative 5 feet per second. And then again, the initial velocity that we are going to use is the velocity in 8 seconds, which is 25 feet per second. So again, formula for change in velocity, we have integral of a dt. Acceleration, which is negative 5 dt limited to 8, and then the time that is unknown. So integrating, we are going to have negative 5t minus negative 5 multiplied by 8. So negative 5t, negative 5 multiplied by 8, we have negative 40. Negative 40 multiplied by negative, that will become positive 40. So this is our change in velocities. Velocity, so negative 5t plus 40 plus the initial velocity, which is 25, is equal to 65. There. So this is our value for velocity for this time interval. So when time is equal to 8 seconds, v is equal to negative 5t. Sorry, substitute na natin. So 5, 8 plus 65. So calculating negative 5, so sabihin natin negative 40 plus 65, that is 25 feet per second. So same sila. That means correct yung ginagawa natin. So when time is equal to yun, yung unknown na time. So paano ba natin makukuha yung unknown time? So di ba meron tayong equation na ito, na negative 5t plus 65. So let us say that velocity is equal to negative 5t plus 65. So let us say that velocity is 0. Let us equate it to 0. So transpose natin to sa kabila, so that will give us 5t is equal to 65. Simplify, divide both sides by 5 to eliminate the 5 and then leave t. So t is equal to 65 divided by 5. So that is 13 seconds. So 13 seconds, in 13 seconds, the velocity is equal to 0. So the next thing that we're going to do is we are going to graph the coordinates that we solved. So there. And then 16 and 25. So this is 16, this is 25, this is negative 8, this is negative 14. So the time frames that we have are 2, 5, 8, and then 10. 10, sorry, 13. So label lang natin. So 8, and then 5, and then 2. So when time is 0, the velocity is 14. Let us use a different. So 14. And then when time is 2 seconds, we have negative 8 feet. When time is 5 seconds, we have 16 feet per second. And then when time is 8 seconds, we have 25 feet. Siya. Ay. There. So when time is 13 seconds, 'di ba? Ang nakuha natin is 0 na velocity. So connecting these coordinates, we are going to have this. Yan. Medyo malabo. There. So since meron siyang tinamaan na time dito, hindi lang sinabi sa problem pero kailangan natin yan i-solve. So sa pagitan nitong 2 and 5 seconds, nagkaroon tayo ng given na velocity na 8t. Sorry. 8 dito na lang. Velocity is equal to 8t minus 24 dito sa time na 2 and 5. So in order for us to get the value of time, let us say that velocity is equal to 0. So let us equate that to 0. So transposing this value, negative 24, to the other side, that will give us 8t is equal to 24. So simplifying, divide both sides by 8, we are going to have given time, which is 24 divided by 8, we have 3 seconds. So the point here indicates that 3 seconds. So that is it for the V. This is for the VT graph.